Hello, hello. I hope you're doing well this morning. Okay, we're drawing close to the end of our course here. Just probably 2 or 3 more of these sessions, which will be about trig, and then we'll be taking our final later on this afternoon. I'm definitely going to be uploading a video and probably an announcement, and probably also an accompanying email in various different formats. In other words, explaining how the final exam is going to work. Okay, probably curious about that. But what's going to happen is this: if you look on your calendars, you will see that there is a day that says a date on your calendars that says last day for tests, right? And on that day, I will be uploading a final exam assignment to you. And it's going to be open book, and it'll be a couple of questions, 1 or 2 questions from each chapter that we've covered this semester. You will answer the questions, right? And then you will upload the document back to as we've been doing with all our assignments. You'll submit the assignment, and that will constitute your final exam for this year for Algebra 2. All right? More detail later in the separate communication this afternoon. Okay? But that's what's coming. Okay, so let's see now. Trig, where are we? Okay, so right here, last time we talked about basically how we measure angles. Okay, we talked about radians, we talked about degrees, we had some questions about arc length and about sector area, right? So today, what we're going to have is we're going to start talking about some definitions and some basic definitions in trigonometry. The basic parts of trigonometry that we learn about first are about the 3 basic trig functions: the sine function, the cosine function, and the tangent function. Sine, cosine, and tangent are those 3 functions. There's 3 other ones, okay, that are called reciprocal functions: the secant, the cosecant, and the cotangent, which we will have a little bit to say about later on. Okay? Now, I know, as I discussed last time, that you ran across sine, cosine, and tangent in your geometry class, in which they were studied and worked and used as ratios inside of a triangle, right? Ratios of side lengths, right? And then you solved various problems involving tangents, right, and sines and cosines using those ratios. Various problems essentially involving right triangles, right? Okay, anyway, so it turns out that there's a lot more to sine, cosine, and tangent than that, and we're going to find out about that today. Okay, so what we've got to start with here is I'm going to upload a blank copy of something called the unit circle. Okay, and I'm going to be working with the unit circle here, and you're going to have on here a video copy of it. And what you should do, and what we would do if we were in class, is that you would have in front of you a blank copy that looks like this, right? And the information, as I work through it with you in class, as we work through it together, you would fill it out onto this unit circle. You would write the information in that I'm about to tell you onto this unit circle. You should still do that. Okay. Now I'm going to upload a regular, my own completely written out copy, but it's better for your learning if you make your own. Okay. All right. Anyway, so the sine, cosine, and tangent, which are the 3 functions that all trigonometric, the field of trigonometry is based on, are defined according to something called a unit circle. Now, it's called a unit circle because, well, it's a circle, okay, and it has a radius of 1. Unit meaning 1, like a unicycle, right? So that's a radius of 1. Now, if you remember from our conic sections unit, that if we graph a circle like that on the xy plane, it has an equation. So we're going to put our unit circle, we're going to put the center of the unit circle at the origin. Okay, right there at 0, 0. Okay? So that's where that's going to be. Get some other colors out here too. There we go. So that's the center of the circle at 0, 0. And if you're a circle whose center is at the origin and whose radius is 1, it had an equation, right? Remember that in the world of circles, circles had this equation where h and k was the center of the circle, right? Which for us is going to be 0, 0 on the unit circle. R was the radius, so this is r squared. So for us, the radius is going to be 1. And x and y was a point on the circle somewhere. Okay, now since the center of the circle is at 0, 0, and the radius is 1, the equation for our unit circle simply boils down to this very important equation, x squared plus y squared equal to 1. So you want to keep in mind that when we discuss the unit circle, we're talking about a circle on the xy plane, okay? And that's the x, and this is the y right there, by the way. Let's make sure we know that, okay? And the radius is 1. And since it's a circle, the radius is always 1, you know, wherever it is you go around the circle. So that distance out there is 1. And this distance here is 1. And this distance here is 1. And that distance right there will be 1. Right? And then this distance right here will be 1. Now because of that, because we know the radius is 1, we can actually say something about what the coordinates of the points on the circle have to be. So for instance, right here, out there on the xy, out here on the x-axis, right? This is the x-axis and this is the y-axis, right? That has to have coordinates 1, 0, doesn't it? Right? And up here, this has to be 0, 1 because the radius is 1. This has to be -1, 0. And this has to be 0, -1 down there. Okay? Now, all the other points in between, all the other points on the circle also have coordinates as well. But they have to make this equation true. Okay? So, we're only going to be, in our trig study here, we're only going to be concerned about points on the circle. Not points outside the circle, not points inside the circle. The points of concern to us are points on the circle. And we're going to see the sine, the cosine, and the tangent functions all defined in terms of this unit circle here. Now, if you watched our videos last time carefully, you'll remember that when we worked with like angles, when we defined angles, and when we define either for degrees or radians, we used a circle, right? And we said, oh, we're going to have an angle, right? Let's say this one right here, and we put the center, the vertex of our angles, theta we called them, at the center of the circle, right? And we measured the degrees here, or we measured the radians here on the circle, right? And you can see, and this is important, and we said also, by the way, that when we measured our angles on the circle, we always started from this horizontal axis right here. So when we measure, and that's going to be true for our unit circle too, because we're going to be measuring angles on this unit circle along with the points of the circle, okay? That when we measure an angle, one side of the angle will always be at this horizontal axis here that goes out to 1, 0. For us, that's going to be angle degree 0. And then we're going to measure positive angles counterclockwise like this, and negative angles clockwise like this. So for instance, right here, this angle theta here will be the angle from here up to that other side right there. Okay? Now, so what's important about the unit circle, and we'll see more about this later on, where this all comes together, is the idea that each point on the circle, each XY point here, right, that actually can be paired up function-wise with a corresponding angle. Each angle here will go with a point XY on the circle. Let me make another color over here. So this angle over here, I'm going to put another side over here. There's another point over here, x comma y, a different xy than that one. And there's going to be an angle here. Let's call that angle theta. That's associated with that point x comma y, right? So that's the unit circle here, and we can go all the way around, right? And there'll be more to say about this later on, but remember the idea that that as we go around, we can either go in a negative direction to get to this point xy, or a positive direction to get to that xy. But I'll fill those details in later on, okay, after we've spent some time with the unit circle, okay? Now, so this is kind of a brief, very brief outline about how our unit circle is going to work and about how our functions are going to be defined. That there's going to be a point x comma y on the unit circle that fits this unit circle equation, and each one of these points xy can be associated with an angle that we can measure from over here from the 1, 0 point. This would be angle measure 0. And this would be angle measure theta, and all the way around back to 360 degrees, okay? All right, very good. Now, so what I want to do here is we're going to take this in two stages, okay? First, we're going to, now with that intro here, first we're going to talk about what the XY points are, what those coordinates are, okay? Both in radians and degrees. Then we're going to talk, and this will be probably, I think I'm going to start up another video for that, because that'll be a longer piece. Okay. Once we've done that, and we've said, well, what are these XY coordinates going to be? We know some of them: 1, 0, 0, 1, -1, 0, 0, -1. Okay. But what are some of the other XY coordinates going to be? All right. And then we'll talk about what the angles are in terms of, the corresponding angles are in terms of radians. Okay? All right. So I'm going to stop this video right here, and then we will immediately go to this here. Now I'm going to suggest that when you start up the next video, I'm going to have this blank picture here linked, right, that you have printed out a copy of this right in front of you so that you can follow along with what I'm going to do on the next video. Okay? All right. Toodaloo.